Here we'll look at the standard form of the quadratic function, or the standard form of the parabola. The first thing we'll do is find the vertex. Let's look at this problem. F of x is equal to negative 2x squared minus 4x plus 6. That's standard form. In standard form, the coefficient of x squared is a, the coefficient of x is b, and the constant we call c. To find the vertex, again, this is the minimum or the maximum value, we can use this formula. We find the x component of the vertex by evaluating negative b over 2a. For our equation, f of x is equal to negative 2x squared minus 4x plus 6, the coefficient of the x squared term, or a, is negative 2. The coefficient of the x term, or b, is negative 4, and our constant, or c, is positive 6. So negative b over 2a in our case is negative 4 divided by 2 times negative 2. That leaves us with a positive 4 in the numerator and a negative 4, which gives us negative 1. Now to find the y component of the vertex, we want to find the y value that corresponds to the x component we just found. In other words, we want to evaluate the function where the x has a value of negative b over 2a. In our case, we found that negative b over 2a was equal to negative 1. So we'd like to find the value of the function where x is equal to negative 1. So we want to find the value of y where x is equal to negative 1, or evaluate f at negative 1. So we simply take negative 1 and substitute it in for each instance of x in the original equation. So we take negative 2, multiply that by negative 1 squared, subtract 4 multiplied by negative 1, and add 6. Do be careful again here to make sure that you leave that negative 1 in brackets. This gives us negative 2 times positive 1 plus 4 plus 6, or negative 2 plus 4 plus 6, and ultimately positive 8. So the vertex of this function is at the point negative 1, 8. Does this parabola open up or open down from the point negative 1, 8? Well, to answer this question, we look at the value of a. Since a has a value of negative 2, we know that this parabola will open downwards, and the vertex, negative 1, 8, will be a maximum value. A reminder that standard form means that our equation has the form f of x is equal to ax squared plus bx plus c, and therefore c is the y-intercept of this parabola. Why does that happen? Well, the y-intercept happens where x is equal to 0. So as soon as we see that we have an equation in standard form, as we do here, let's see what happens when we substitute in a value of 0 for x. We get a times 0 squared plus b times 0 plus c. Anything times 0 is of course 0, so this evaluates to simply c. We have 0 plus c. To find the roots, or the x-intercepts, we'll use either the quadratic formula, or if you know how to factor, we can sometimes factor the equation for a fast way to find the roots. We'll look at this same equation we looked at on the previous slide, where f of x is equal to negative 2x squared minus 4x plus 6, and find the y-intercept and the roots for it. Let's start with the y-intercept. That's the easy one. Again, for the y-intercept, we set x equal to 0. F at 0 is equal to negative 2 times 0 squared minus 4 times 0 plus 6, or just positive 6. In fact, we don't need to put the work in here. We can simply write down that the y-intercept is equal to the value of c. c is positive 6. We find the value of the y-intercept is positive 6. As a coordinate point, This is the point x is equal to 0, y is equal to 6. We'll use this to graph our function. Now let's find the roots, or the x-intercepts. The y-intercept we found by setting x to 0. Similarly, we'll find the x-intercepts by setting y equal to 0. That means we'll set the value of the function equal to 0, and that leaves us with the task of solving for x. For reference, here's the quadratic formula. We find the x-intercepts by solving negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And recall that the a, b, and c come from the standard form of the parabola, which is f of x is equal to ax squared plus bx plus c. We previously saw that a has a value of negative 2, b has a value of negative 4, and c has a value of positive 6. Our job is now to take the values for a, b, and c and put them into the quadratic formula. That gives us our values for x. So in our case, we have negative b, or negative times negative 4, plus or minus the square root of b squared, so negative 4 squared, minus 4 times a, which is negative 2, times c, which is positive 6. And all of that is divided by 2 times a, in our case, 2 times negative 2. All that's left to do here is to simplify. We have x is equal to 4, plus or minus the square root of 16 plus 48, all divided by negative 4. X is equal to 4 plus or minus the square root of 16 plus 48, which is 64, and the square root of 64 is 8, and all of that is still divided by negative 4. This gives us our two answers. So either x is equal to 4 plus 8 divided by negative 4, or x is equal to 4 minus 8, all divided by negative 4. In the first case, we get 12 divided by negative 4 is negative 3. And in the second, we get x is equal to 4 minus 8, which is negative 4. So negative 4 divided by negative 4 is positive 1. What does it mean that x is equal to negative 3 or x is equal to 1? Well, those are the roots, and we found them by setting y equal to 0. So we found the x-intercepts, and they are the coordinate points negative 3, 0, and 1, 0. So we'll use these key points to graph our parabola. We found that the vertex had a value of negative 1, 8. We have a y-intercept of 0, 6. And the two x-intercepts, these are real values, and in fact they were rational values. And these were negative 3, 0, and 1, 0. So we plot the vertex at negative 1, 8, up here. The y-intercept, 0, 6, is this point. The x-intercepts are negative 3, 0, and 1, 0. It's also easy to find a fourth point, remembering that there's an axis of symmetry. That means that we also have the point negative 2, 6 across the axis of symmetry from the y-intercept. This gives us enough points to have an idea of the shape of our graph, so we can sketch in the line that you see here. A parabola doesn't have any straight portions to it, and it doesn't come to a point, so make sure that you graph it using a smooth line.